Hello everyone. Today is the 8th day of Leetcode 75 challenge. Let's begin with the 8th question. Question number 334, increasing triplet subsequence. And the level of the problem is medium. I will request you to read the questions beforehand as I will deep dive into the PPT and explain it in simpler way. So we are being given an array of numbers. Okay. And our task is to find a sequence where they come in increasing order. So basically the numbers I, numbers j, nums k should be in increasing order. Fine. Their position in the array follows this pattern. IJK. This is the index, which means the first number should come before the second and second number should come before the third. Okay. Increasing indexes can be non-contiguous, which is not mentioned in the question. So please make this clear. It could be non-contiguous also. Return true and false. So they are saying that numbers should be in increasing orders. Okay. And also their indexes should be in increasing orders. So this is index, this is number. And they want true or false as a output when this condition meets. So what is a constraint? Constraint is that length nums of length would go from 1 to 5 to the power 5 into 10 to the power 5. And num value could be from negative minus 2 to the power 31 to positive 2 to the power 31 minus 1. Okay. Now let's move to the next slide. Let's understand the input output of the problem. If we take the example 1, we have been given 1, 2, 3, 4, and 5. Okay, output is true. How? It will be 0, 1, 2. Let this be the indexes 0, 1, 2, 3, and 4. Okay. What the conditions is that the value should be in increasing order and they could be non-contiguous also. So it is increasing. Great. And index is also increasing, right? 0, 1, 2. So it becomes true. Okay. Now let's understand this example 2 here. 2, 1, 5, 0, 4, and 6, right? Okay. And indexes are 0, 1, 2, 3, 4, and 5. Okay. So this is 2. So here we can see that 0, 4, 6 is increasing, right? And their indexes are also increasing. And what else could be said? 1, 4, 6. 1, 4, 6 could also be an answer. Indexes 1, 4, and 5. 2, 4, 6 could also be an answer having 0, 4, and 5. So that's why both the outputs are true here. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem, right? Let's imagine you are on a treasure hunt. You have a magic bag that can only carry two things at a time. The smallest treasure you have found so far, let it be the first small treasure, let this be a first small treasure. And the second smallest treasure you have found so far. Second smallest will be, if this is 1, this would be 2, right? Now, okay, we have this, we can carry these two things, right? Now we are walking along a path, and that is array in this case, full of hidden treasures, which is basically the numbers. If you find a smaller treasure, then we will put it in our bag, in the first bag, right? And we will replace it because you want always want the smallest treasure first, right? For example, if in the like if we will replace that. So it is going in this way. If we had some values in the first bag previously, 3 or 3, let it be 3, and we came across another value after 3, which is 2. Now this is 2 is smaller than 3, right? So our task is we have to find the first smallest number. So in this case, 2 will be the first smallest number, right? So we will remove this 3 and add it 2, right? Okay. And after that, if the treasure is bigger than the first treasure. So now we have 2, right? And if after going few steps, we got 4. Okay. So this is bigger than the first bag or the first treasure, right? So of course this would be the second treasure, right? And now imagine in the second bag you already had one value 5. Okay, so you cannot take 5 in this case. You have to take the 4 because it has to be the second smallest, which is greater than the first smallest, but smaller than or equal to the present value in the bag. So we will replace 4 with 5 and we will have 4 in the second bag. Okay, now you have two increasing treasures. Now, if you find the treasure bigger than both the treasures in your bag, and after this scenario continues 3, 4, 4, 5, 1, 3, and at the end, or not at the end, even if the third value comes out to be greater than the both values, like let it be 6, so it becomes 2, 4, 6, right? And we got the output. So this could be our intuition, right? We could take two bags and keep the smallest one in the smallest bag, second smallest in the third bag, second bag, and the greatest of all both of two in the third bag. Okay, and we will keep on going. If we find a number which is smallest than the current value in the first small bag, we will have it. But if it is greater than the first bag, we will check the second bag, and if it is smaller or equal to the second bag, we will add it there. But if it is greater than both the values, then it will be in third bag, right? So this is the intuition we could take, that we have to find the smallest and the second smallest value every time we get a value and try to replace them in the bags. So I understand that you will be understanding this intuition. So let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach, how we're gonna solve it. This approach is simple and easy. There is nothing much complex here. So I will try to make it much easier for you. So it is this way. Declare a variable and to store the length of the given list. This is the compulsory thing. We need the length as we will iterate the array. So n. And as I said, we will be having two bags. First small bag and second small bag to store the first small element and the second small element, right? Now, I also said in the intuition that if bag contains something, if the coming value is smaller than or equal to that value, we have to replace it, right? So since initially we don't have any values, we will take float in both the values, and that would be infinity, because if it is something minus 1 lakh, sorry, if it is something like positive 1 lakh, and if in the first bag, and if we get 2, we will replace it, right? With 2, with 1 lakh with 2. No, that's right. Now we will iterate, and this will help you storing the first and second values. Now we loop through the each number in the second step. Now we are looping through. If the current number is smaller or equal to the first small value, it means we have found a new smaller number, and so we will update the first small, right? This is the first small, and it has infinity in it, and we got a number, for example, less than this, let it be 3. So we will replace it, right? Because this is the first smallest number we found till now, right? So the first small will be having 3. Okay. Now, if the current number in the array is smaller or equal to the second small, this condition automatically satisfies that the number which we have received in this condition would be greater than 3, or first small number, right? Let it be 5. And since in the second small also we were storing infinity, so this is smaller than the element in the second small, so it will be replaced by the second small bag. I have created a bigger circle to understand this is a second small bag, and smaller circle for this first small bag. Okay, so this is done. So this condition also, as I explained, but it is greater than the first small, so we'll update the second small. That will be an else condition for us. Now, if the current number is bigger than both first and second small, right? As I said, if we have got 3 and 5, and our condition is getting satisfied, and we are keeping continuing the this thing again and again. And as soon as we touch a value in the array which is greater than this also, greater than this also, let it be 7. We will just check in as soon as we come in this else case, we will return true. Why? Because we got the two values which are in sequence, and we are iterating array from 0 to n minus 1. So there won't be any iterations 2 times or 3 times. It will be a one iteration, and the values will be placed one times only. right? As soon as we get the third value, which is greater than the second value, we will return true. So this means we have got a sequence which fulfills all the condition of increasing index, non-contiguous, increasing values, non-contiguous. Okay, so that only is step 3. If no triplet is found at the end, after the loop ends, we will return false. Okay, so this is the approach. Approach is not that complex. It is easy to understand, and it's just the intuition which we have to understand about the problem, how we're gonna solve it. Now let's move to the next slide. The code is exact copy of the approach discussed. Let's understand it line by line. We will declare variables first small and second small. Done. N for storing the length of the nums, and we will iterate. Right. This is the condition for first small and second small. As soon as we get the third value, which is greater than both, we will return true or we will return false. Right. So so this was the intuition. Like if nums of I is less than the first number, so it will replace the value, and if nums of I is less than second small element, so it automatically satisfies that it is greater than this value, right? And if this also fails and this also fails, the if conditions automatically satisfies that it will come in else, and that is the biggest value of compared to both. So it was the intuition which we had to find of iterating a problem in O of n solution. As you can see, the time complexity of the solution is O of n, and space complexity is O of 1. So this could be the one tricky thing to find out how to solve the problem in O of n solution without using any extra space. So this is the way. It could be tricky for some people, or it could not be, but the approach is simple and straightforward. So if you that's all. The approach is easy and straightforward. I would like you to read the approach again if you have not understood. Try to read the intuition again and understand the code again. I think this will help you to understand how the approach is going and how the code is getting typed. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Let's take this example itself. 2, 1, 5, 0, 4, then 6. Okay, let this be the array. Let this be the indexes 0, 1, 2, 3, 4, and 5. Okay. I'm initializing fs means first small, ss means second small. Okay. Now they contains infinite value. Okay. Now we are in I2. What our first condition is to check if nums of I is less than or equal to first small, right? And then L if n of I is less than or equal to second small, else return. Okay, so we will trigger the first condition now. N of I, which is 2, it is less than first small. Yes, it is. We will have 2 here. Okay, we will move ahead. Now we come to this index 1. Value is 1. Now is 1 less than 2? Yes, we will have 1 here. Okay. Now we came to the third index, which is 5, right? Is 5 less than 1? No. So this condition fails. Is 5 less than infinity? Yes. So we will remove this from a variable and add 5 there. Okay. This is done. Then we'll come to this index. Index 4 value is 0. Is 0 less than 1? Yes, it is. We will cut 1 from here and enter 0. Okay. Now our I is here. Okay. In the fourth index, the value, in the fifth index, the value 4. Is 4 less than 0? 4 is less than 0? No, right? But is 4 less than equals to 5? Yes, it is. So we'll remove 5 from here and add 4 to it. Okay, this is done. Now we are in the last index, the value 6. Is 6 less than 0? No, right? Is 6 less than equals to 4? No. What does this mean? This means that this 6 is greater than both the values, right? 0 and 4. So we will return true. Instead of storing the value, we will return true as we got the sequence of increasing numbers and with increasing indexes, which could be non-contiguous. I hope you understood this dry run, and I would request you to take 2, 3 more examples and solve it yourself so that it makes you more clear how the approach and intuition along with the dry run and how the code is working. So let's move to the next slide. Now, since you're familiar with the problem and solution, let's move to the lead code and code out the solution. We declare first small with float of infinity. Second small float inf n equals to length of nums so that we can iterate for I in range n if our first condition if nums of I if it is less than equals to first small, right? So first small will become nums of I. L if nums of I is less than equals to second small. So second small will be nums of I. Okay. Else values greater than both the first small and the second small will return true. Else will return false. Okay, we have passed the test cases. Now let's submit the solution. Okay, our solution has been accepted. The code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.